Hello everyone. We're going to be talking about graphical analysis. We will be doing a lot of that in physics this year, so it's really important that It's important that we get good at drawing good graphs. All right, so this is a graph I'm going to be working on right now. If you'll notice, there are a few things missing from this graph, namely a title and labels for our axes. So let's just pretend this is a velocity time graph, and we will label our axes accordingly. It's not important right now what quantities these are, just as long as we have our labels on here. So velocity is our variable, meters each second are our units, time is our variable, seconds are our units. In order to have a complete graph, you need to have both labels for variables and units on both of the axes. All right, the next thing we're going to do is draw in our best fit line. So what you want to do is kind of eyeball it, use a straight edge, and then try and draw the line through as many points as you can. You kind of want to get it through the middle of the points. You want to avoid drawing, connecting the dots, okay? What the best fit line does is takes an average of all your data points, and it gets you a better picture of what's really going on. The next thing we would do is calculate a slope. So to calculate a slope, we would do rise over run. So rise means how much is the y-axis changing, and the run is how much is the x-axis changing. So to calculate slope, we would do y2 minus y1, and we would divide that by x2 minus x1. So if we picked 2 points on our graph, if your graph goes through 0, I suggest using that as one of your points. And then find another point that's at a good intersection. It's much easier if you're doing this on graph paper. So those are whole numbers on my scale, so I would try to use that point. And so we would calculate our slope on this graph as our y2, which is 0.6, minus our y1, which is 0, 0, over 0.8 minus, and that is a 0, okay? You would divide those and you would get the slope of your graph. 0.6 divided by 0.8. What is that? It's about 0.75. So that's the slope of our graph. When we do graphs, we are also going to be looking at interpreting them. So there's several things we're going to look at. One are the units of the slope. So for the units of the slope, we just talked about slope a minute ago. You take the change in y over the change in x. So I'm just going to shorthand it here. And we will be talking about that when we go into our math stuff, what the little triangle means. Right now, they've calculated slope for you, so I'm not going to worry about filling that in. All right, but the units of the slope. Well, what you do is you look at the units for each of your axes. So in this case, our y-axis has units of dollars. Our x-axis has units of compact disc. So our units for our slope would be dollars for each disc, okay? So those are our units. Again, I just looked at what was on the y-axis. That goes in the top. Whatever's on the x-axis is what goes in the bottom. All right, the slope of this graph, what does it tell you? So the slope is 7. So if you look at the units, we could fill in the slope and we could write out our units. So $7 for each disc. So the slope is the cost for each CD. Then it says to write an equation that describes the graph. So in math, you probably did a lot of y equals mx plus b, or you should have done a lot of y equals mx plus b. What that stands for is what's on the y-axis. The m is your slope. You multiply that by what's on your x-axis. And then the b is your y-intercept. And that may not always be a positive number. That may be a negative number depending on what the graph looks like. It could also be equal to 0, which we will see a lot in physics. So to write the equation for this graph, I would put what's on my y-axis, which is the cost. I would put in my slope for M, which is the 7, and I'm going to abbreviate dollars for each disc. We multiply that by the compact disc. And then we add our y-intercept, which in this case is 3.6, okay? Since that's a y-intercept, it means that's where it crosses the y-axis at a value of x equals 0. So that is technically dollars. So I'm going to go ahead and put a dollar sign there. This will help us with the interpretation for the y-intercept, which is what the next question asks us for, because now I can see that my y-intercept is $3.60, which probably means it could be a shipping and handling charge or something like that. All right, so that's how we are going to use graphical analysis to analyze a graph. All right, last but not least, let's talk about the different types of slopes, okay? So I'm just going to do a generic graph here. I'm not going to worry about numbers or anything. Let's just go ahead and call it velocity versus time. Again, that's an easy one. And we're going to talk about these slopes. Lines that are straight have constant slopes. So we could have something that is a constant 0 slope. Oops, sorry about that. We could have something with a constant positive slope. We could also have something with a constant negative slope. Okay, as long as it's a straight line, it's a constant slope. We could put that here for the blue one since I did not label that as a constant slope. Okay, if the slope is changing, it's not going to be a straight line. Basically, you can tell that if I picked this point and I calculated the slope, and then I changed my mind and picked this point and calculated my slope, I'm going to get the same calculation every single time. A slope tells you about the rate of change. It's telling you the rate of change of whatever is on the y-axis versus whatever is on the x-axis. For this graph, the rate of change is the change in velocity over the change in time. That's what the slope tells you about in this graph. Again, if it's a straight line, it doesn't matter where you pick the points because the slope is the same. If it's a changing slope, it's going to have a curved line. So that is a changing slope. We will be looking at graphs with changing slopes eventually, but if you look at this, if I were to pick those 2 points and calculate a slope, my slope would be something like that. If I were to pick these 2 points, then I would have a slope that looks something like that. And as you can see, if I compare the slope to that line to the slope of that line, my slope is increasing. I could compare it to a point down here, and that isn't increasing. So in order for the slope to be changing, it means we have to have a changing rate of change in our variables, and it means you're going to have a curved line graph. All right, if you still have questions, please let me know, and I would be glad to help you out. Have a great day.